So those of you that was not here, we're going to go over a little bit. Did we actually start 9-1? Huh? Yeah, I really don't like 8, so I probably skimmed over 8. This is what you're going to be tested on, so don't worry too much about 8. I'll figure out the homework on 8. But if I don't, what I would not suggest you do is don't go in and do 8.1 and 8.2 homework, because I may delete it.
You already did delete it.
Did I? Okay. Well, there's some hammy squirrels that will go do homework, and even though I told them I don't want them to do it, they'll go in and do it anyway, and then when I delete it, they have a conniption. Yeah, it's what hammy squirrels, they have a lot of them. It's called a temper tantrum. All right, this is what we're going to do. We're going to start on 9.1, and this is actually, from here on out, this is probably what I'll test you on, because, and I have no idea how far we're going to get, so I would highly suggest that you do what I cover. If I don't go over 9.2, I wouldn't suggest doing the homework. If I don't go over 9.8, which there is no 9.8, then I wouldn't suggest doing it. So do not work ahead of me on chapter 9 and 10. All right, so here we go. There is our P hat. We talked about that the other day. And for those of you that were not here, P hat is the ratio or the decimal of x over n, which n is always your biggest number and x is always your smaller number. So that takes care of that. The complement of P hat is what? Q hat. You take P hat away from 1, and that is your Q hat. So P hat and Q hat, everybody in here should know about that.
It's 1 minus P hat?
Mm-hmm.
Q hat? Okay.
It's always a complement.
1 minus.
All right, so here we did, I don't know if we did this or not, but I'm going to do it. This is a good question to put in your notes. Of course, you don't have to write every single word. All you got to write is 1,783 registered voters opposed the death penalty, convicted under murder. 1,120 were in favor. So 1,783 registered voters were surveyed about the death penalty. 1,123 were in favor. What is P hat? That's all you got to write down. You don't have to write down every single word. All right? So, what is N? 1783. Good. 1783 and 1123. So, somebody give me 3 digits.
0.63.
Point what?
6. Exactly.
I ain't heard a word you said yet.
0.63.
Thank you. Pronunciation, volume. Thank you. Especially if you're in the back 40 with the Southern Baptist back there. Okay? All right? If P hat is equal to 0.63, what is Q hat?
0.3 is that.
Good job. Now, the reason you're going to need that is because the formulas, 2 formulas that we're going to go over today, are going to use both of them. Capiche?
Yes.
Okay, so that's, we covered this a little bit with 8.1 and 8.2, and remember I told you out of 8.1 and 8.2, that's what I wanted you to remember. So make sure you can find P hat. How else can P hat be given? It can be given like this, which is words, okay? And this is very unofficial. No book is going to tell you this. This is a Hubertism. They're either going to give it to you in words, they're going to give it to you as a fraction, or a ratio, or a ratio. Or 3, they'll give it to you as a decimal. Okay? In other words, they can have it written in words like that with numbers, or they can give it to you and say 1/2, or 427 over 628. Or they can say 0.26 or 38%. It can also give you a percent. So if they give it to you like this, you know what to do. But if they give it to you and say, in July 2008 at Quinnipiac University, polled registered voters and found out that 32% were in favor. Then P hat would be 0.32. Q hat would be 0.68. So in these questions, in Chapter 9 questions, they could give you 2 or 3 different delivery systems for P hat. You just got to be aware of it. Please do not sit there and if they say 32%, just stare and look at it and say, well, I don't know, I can't find X and I can't find N. No, they've already given it to you. P hat is a decimal. Okay. I'm trying to find my cursor. You know, it's just, we should just cancel class.
I mean, okay.
All right.
By the time I got home, I'd get a phone call. Anybody want to bet me?
Let's have a vote.
Let's have a vote.
No.
Are you sure?
No.
Why?
Because the person that's always won is not going to sit here and say, I'm right here. I'm the person that's going to mess up your whole life for the rest of your life.
There's nobody in here today.
You don't know that.
I think I do.
I'm going to tell you one thing. If you go through life with the attitude that there is not always one, your butt's going to get in trouble.
Uh-oh.
Okay, because whatever office you work in, there's going to be always one person. Whatever school you go to, whatever class you go to, there's always going to be one person that's going to ruin it for everybody. Always. Remember that. Whenever you try to get away with something in your job or whatever, there's going to be one person that's going to tell on you. Always. You don't believe me? Just go ahead and not believe it and see what happens. All right, let's talk about these 2 guys. Make sure you write down both of them. Confidence interval and confidence level. They're 2 different things. They're written 2 different ways. Actually, confidence level comes first. Okay? Now, nobody ever sits here and calls it the level of confidence. In all statistics courses, mostly all I've seen, it's always referred to as confidence level. But in this book, it says level of confidence. Now, what does level of confidence mean? It says exactly what it means. I am 90% confident. I am 98% confident. And remember, we're going to make an index card. I did it with the morning class this morning. It's on that video, as well as tonight. We're going to make an index card. I told you to bring an index card. Of course, one of you did. Yeah, probably. Miss Cheater. Oh, wow.
See?
Oh, my gosh. I think we better just quit right now. Oh, my gosh. I think all of you brought one.
Aren't you proud?
There'll be one person. I guarantee you, if I went around the room tonight, one person would not have one. There she is. You not only failed this course, you failed the calculus course too. So, see, that's the person right there that does all the. You do all the work, and he sandbags. Just like a manual. That's all their work. Anyway.
Oh, wow.
That's true. All right, confidence interval. The confidence interval is going to look like this. Confidence interval is going to look like P hat in the middle, and I'm just going to use 0.44 and 0.48. That's an example. Now, from the confidence interval, if you're given a confidence interval in a problem, standardized test question, or a test question, you can find 2 things from the confidence interval. Can anybody name them? Just have probability and statistics before. Okay, y'all settle down. Not everybody answer at once. Okay? One of them, you can find the margin of error. Mode. The second thing you can find from the confidence interval is the P hat. You can find the P hat. So, the reason this is an important thing for you to understand is because on standardized tests especially, they will give you something like this and they'll say, what is the margin of error? And that's all it'll say. And most people sit there and stare at it for 15 minutes. It's real simple. All you got to do is just a little bit of basic math.
You said the margin variable, that's the mode?
Hold on, I'm trying to teach you. One, you can find the margin of error, mode. And B, you can find P hat. If you're given the confidence interval. Now, what was your question, Ms. Judy?
Oh, you just answered it.
Okay, I'm sorry, I was just trying to teach. Okay, margin of error is basically given right here with simple math, okay? What is the difference between 0.44 and 0.48?
2.
It's 4.
I mean,
But-
yes, 4,
yes.
yes, sorry.
Okay, and what's 4 divided by 2?
Sorry.
0.02. So the margin of error is equal to 2% or 0.02. And how'd you get that? You found the midpoint. Basically, 0.48 minus 0.44 divided by 2. And that gave you 0.02, which is 2%. So just looking at the margin of error, the confidence interval, I could find and calculate the margin of error, which was 0.02. Now, to find the P hat, all you got to do is remember your midpoint or your mid-range. You take the lower plus the what? And divide by what?
2.
So one you subtract and divide by 2. The other you add and divide by 2. So 0.44 plus 0.48 is 0.92. Somebody help me out. And 0.92 divided by 2 is what? Dang old 0.46? Somebody help me out. Now, of course, there's always going to be somebody who goes, well, all you got to do is just do that. Well, fine. Okay? You invented it. We'll just give you credit for inventing it. Okay? I'm just telling you how to do it if you have no idea what you're doing. Okay? That's how you find the midpoint. I can't even talk tonight. Why don't somebody else?
The margin variable?
The margin of error and P hat. Now, what else can I find since I found P hat? So strong, isn't it?
Q hat.
Q hat. Q hat is 0.54. So you can go over here and do Q hat is equal to 1 minus 0.46, which is equal to 0.54. So just by being given the confidence interval, you can find not 2 things, but 3 things. So make sure you know how to do that, because there'll be a homework question or a test question or a standardized test question, and all they give you is the confidence interval. And they may ask any one of those 3. So, what is the confidence level? Well, we're going to get out of this now. Well, go ahead and write down what you can. You don't have to write it word for word. But basically, it's the level of expectation. Okay? That's basically what it is. It's the confidence you have pretty much on your work. Okay? Now, all this is going to fit together, hopefully, in the rest of the unit. So we're just going to go through it slowly, because I'm going to tell you, out of all the units we've gone over, this one is the one that gives students the most trouble. So that's why I'm going real slow.
The level of expectation?
Yeah, that's pretty much. Or confidence. You can say the level of expectation or confidence in your work. Now, that's not what they say, but half the things they say you don't understand anyway, so I just put it in layman's terms. Okay? Now, we're going to go to our handy-dandy index card. So that means I'm going to get out of this, and we're going to come back to this slide after we finish. And we're going to go to the whiteboard. Got to lay off them Marlboro Reds, Miss Cheater.
I think it's the Newport.
Them things will kill you.
Yeah, you would know.
Yeah. I smoke 3 packs a day. You can tell it when I cough. It sounds like I'm coughing up a lung. Okay. So, let's take since I don't have posters, we're gonna take a, I'm gonna,
We're gonna make it.
yeah, I'm gonna make a toaster for y'all. Look at there. I need training on this thing. Look at there. Isn't that something? And I'm even gonna take it one step further. I'm gonna, yeah, and I bet you know what else I can do? I bet you I can hit that, and I can copy it, and I can do, I wonder what duplicate means. Oh, hell. Oh, my. Look at what I can do. I need training. I don't know how many I'm gonna make. I need to make 10, but we'll just figure it out as we go. Y'all are impressed, aren't you?
Yeah, we are.
That's a trick I learned in the war.
Everything you learn in the war.
Yeah. Actually, that comes from a guy. He used to say that all the time. He used to drive me crazy. I was in the Marine Corps with him, and that's what he would say all the time, and that's where I got it from. That's a trick I learned in the war.
So now you,
And he never did. He just made that stuff up.
so now you do it to other people.
There we go.
Give it
Yeah.
to us, and then that drives them.
Of course, doing it in this setting with the class with students, they believe everything. I mean, we live in a we're going to start a revolution. Half the people right now in high school can't even start a lawnmower, much less a revolution. I'm going to start a revolution. Yeah. You can't even start your own car.
Oh, yeah.
You can't even jump your car off the jumper cables. You go start a revolution.
Let's do a poster for them.
All right, I ain't going to. Oh, shut up, Hubert. I'm going to duplicate. There we go. Woo! Oh, I'm sorry. Propagate. That's a word that WebAssign uses. It doesn't use the word copy because copy must be redneck. It uses the word propagate. Yeah, somebody's Googling that right now. He made that word up. No, I didn't. Is that 10? Hell, I don't know. Is that 10 lines?
3, 4, 5, 6, 7, 8, 9, 10, 11.
It's 11. Okay, well, that's good enough. I add one on the bottom. Oh, we're going to do something else now. We're going to put vertical lines.
Okay, he finna,
Yeah, I know how to duplicate now. They don't sound good, but anyway. We're going to duplicate. Y'all got a dirty mind.
Is this class gonna be recorded?
Oh, yeah, probably. I didn't say anything bad. I just said people can't start a lawnmower, that's all. That is funny. These people do say they're going to start a revolution, and they can't.
Oh, my God.
They can't even make changes to cash register. All right. Boy, that does look good, doesn't it? Y'all can take a picture of that and print it out. All right, the first one is going to be called confidence level. And I can't even write. I want to start. That's the second time I've wanted to start confidence level with an L. CL. Confidence level. And we're going to go 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. I'm going to add one on the bottom, but I'm going to do that in just a minute. Now, why am I not including 100?
Because that's
Because nobody's perfect. Okay? Why am I not including 78? Because you don't want to present at 78% confidence level. If you walk into a presentation and you're presenting and you say, I'm 78% confident, you're either going to get fired or somebody's going to run you out of the meeting. Now, there's homework questions with 78 and 81 and 85, but that's just because after you do 10 problems with 90 through 99, you're going to use all those, so they just make the other numbers, okay? But this is what you really want. You really want these confidence levels. So, if the confidence level is 90, then alpha is equal to the complement of the confidence level. So what would alpha be? 0.10. We're going to go ahead and call these decimals if you want to. And you could, right here, say 90%. 91%, and so on, okay? 99%. You can add that, okay? So, this is going to be 0.09. This is going to be 0.08. Y'all got it. 0.06, 0.05, 0.03, or 4, 0.03, 0.02, 0.01. And this next one is going to be called alpha divided by 2.
What does COMP stand for?
Complement.
Okay.
So now I want you to divide a dime by 2, and you don't need to use a calculator to divide 10 cents by 2. What's a dime divided by 2? A nickel. I guarantee you somebody already reached for the calculator.
I'll put it down.
What's 9 cents divided by 2? 0.045, 4.5 cents. Okay, now see if you can get this one. What's 8 cents divided by 2? And you know what? There's going to start a pattern here. I bet this is 0.035. I bet this is 0.03. I'm not even doing any math. It's a miracle. So there's your alpha over 2's. Now here comes the part that you need to card for. The next column is going to be called Z.
What's 99?
What's 99?
Oh, I skipped one. Where I skipped one?
Right here, the third row. What's 99?
Third row.
Right here at the bottom.
Very end.
I know, but I skipped one somewhere.
Right here, 99. Cross.
You're not understanding what I'm saying.
Oh!
0.015. Okay, somebody say where I skipped. Oh, 0.005. Thank you. I skipped that one. I see what you're saying, Ms. Jude. I thought I skipped one up here. You're
I'm just
right.
gonna be quiet.
You're right. Okay, now Z sub alpha over 2. That's going to be, this is the area based on this is the area, sorry. And this is the Z-score that you're going to get for that area. So let's go ahead and I'm going to add, and since this is area, I got to add 2 more what? I got to have 4 digits. Because in the last unit, Hubert, you said 4 digits. Yep, I did. So we're going to add zeros. So that way you'll remember on your card that these are what? Areas under the curve. So here, I'm going to put in red, since I don't have any posters for y'all, we're going to put inverse norm. What is it? Second bars? Second bars, inverse norm. So somebody take inverse norm, and also add one more thing. I'm going to put this in highlighted magenta. What do those 2 lines mean?
Absolute value.
Absolute value means always the distance between that number and 0. So it's always going to be what?
Positive.
Or it's going to be not negative or not positive, it's distance. So actually I like to say distance because it's not positive, it's distance. But anyway, that's split hairs, we're not going to worry about it. So there's not going to be any negatives over here, there's not going to be any positives either, it's going to be distance. So somebody take your handy dandy calculator and do inverse norm 0.0500 and you should get 1.635. Check it to make sure I'm remembering from morning class correctly. Is that what you got?
I got 1.645.
45, okay. That's why I wanted y'all to check. I've had a few since 8 o'clock this morning. All right, now y'all fill this out. You got 9 more to go, or 8 more to go. And this is what needs to be on your, and you'll see why in just a few minutes.
tell you what all this is about.
I figured y'all be lobotomized.
She's Japanese. I know, she was something niece.
I'm gonna have to leave those comments alone, because anything I'll say will be held against me and I'll be called a racist, so I'm not gonna say anything. Why? Because I'm a white male, I'm already racist. I am. I'm a piece of crap. At least that's what my mama tells me. All right, what's the next one? 0.0450. The rest of them will probably be like 2 digits, but okay.
1.7.
1 point what?
7.
Is it 1.70 or 1.69 or what?
1.695.
1.695. Let's use 3 digits then. Okay, what about 0.0400?
1.751.
0.0350.
1.812.
1 point what?
812.
0.0300.
1.881.
1 point what?
881.
0.0250.
1.960.
960.
Yes.
0.0200.
2.054.
0.0150.
2.170.
0.0100.
2.326.
326.
Mm-hmm.
And 0.0050.
2.576.
2.576.
Mm-hmm.
Okay, somebody check those and make sure we don't have a mistake, because we're going to use them in the next couple of slides. Now make sure before you take this test, you have this on the index card so you don't have to do it on your calculator 15 times on the test. Now on the last one, let's do 75%. And the reason I'm going to do 75% is so you can see when you're doing a homework problem, if you're given something besides this, what do? You just subtract it from, we're going to do 70. Let's do 76 to make it easy. I'm going to do this in a weird color. Let's do it in this magenta, or this burnt orange. I'm going to do 78%, 0.78. And that's 78% confidence level. This would be like a homework problem, and they might give you 81%, they may give you 85%, they may give you 72%. So that's going to be 0.2, what, 8? 0.22? Right? Is that a compliment? Okay, you said correct. Nobody else is saying anything. So 0.22, what's 0.22? What's half of 22 cents?
11.
It's a miracle. And y'all did that without a calculator, didn't you?
No.
Oh, you didn't? 0.11, 0.1100 inverse norm. Tell me what you get. It's going to be way lower than 1.645.
1.227.
1.22 what?
7.
And that is what you would use for the z-score. So just be in mind that usually on a test, you'll be doing 90 to 99. But on homework problems, you could be doing any number. The first thing you do is find the complement. Find the complement, that's alpha. And then after alpha, you divide it by 2. And then you put 4 digits here, and you put that in the inverse norm, and that'll give you your z-score. And basically, this is what we call our z-score of alpha over 2. Okay, alpha is the little fish-looking thing, alpha. So that is confidence levels. Confidence levels are given, And when they're given, this is what you're supposed to do. Whichever one you've given, that's what you're supposed to do. You're supposed to find the complement, alpha over 2, take the complement, divide by 2, and then find the z-score for that area. Okay? So the confidence level only gives you one thing. It gives you that z-score. Now, let's go back to our handy-dandy slide, because it's going to give us the next example. Okay, I don't know what that's not the example I want. Let me go, oh, I know why it's not working. I get the slideshow. There we go. Okay, this is your confidence interval. You don't have to write this down because I've already showed it to you. Okay, so I'm going to go past the next page because I don't like, we're going to go past that. Go past it. Okay, write this down. For a simple random sample, you've got kind of 2 tests that you need to do. All right? There's 2 tests that you have to do. And plus, most of these, if I give you one of these on a test, it's probably doable. I'm not going to sit there and try to trick you and say, well, let's put one on there that's not doable and see if they get to do the test. I just want you to be aware of it. Okay? NPQ has got to be greater than or equal to 10 when you do one of these problems. Okay? So NPQ, test number 1, NPQ has to be greater than or equal to, NPQ has to be greater than or equal to 10. So if I take NPQ and I multiply them together and I get 9, you can't do the problem because it's not mathematically correct. Which you're not going to have to worry about that on my test because I don't do that. And we also require that each trial be independent when sampling from finite populations. So that means that n, little n, has to be less than or equal to 5% of big N. So little n, has to be less than or equal to 5% of big N. So let's say they give you n is equal to 100, okay? And they say big N is equal to 100. Therefore, 5%, 10% would be 10. 10% of 100 would be what? 10. Therefore, 5% of 100 would be what? 5. So little n has to be less than 5. And of course, you might see a homework question that shows you that test after you've done the problem or something. I don't know. Okay? That's just something that you need to be aware of if they ask you. And that is, little n has to be less than or equal to 5% of big N. And NPQ has to be equal to 10. So if I give you P is equal to 0.4, then you'll say Q is equal to 0.6. And okay, N is equal to 500. Well, let's see. 10% of 500 is what? 50. So that's going to be 500 times 0.4 is 50. That'd be 200, right? Let's see. Yeah. 50, 10% times 4 would be 200. And 200, half of 200 is what?
100.
Is 100 greater than 10?
Yes.
Yes. So you have to, if they give you NPQ, they might say, can you do this? Or can you go further with this question if you're given NPQ and whatever? That I don't know. I have to see. They may give us an example here. I don't know, but you need to know those 2 little tests right there. Okay, this is where I want to skip. I want to skip that one. There. There is your formula for margin of error. Because I show you how to do the interval a little bit different from the way the book does, so I don't do that other formula. This one right here. Now, you don't have to put z sub alpha over 2. You can just put z, because the only z you're going to be dealing with in this one is on that index card. Okay? And that's z sub alpha over 2. So if you don't want to write the alpha over 2, you don't have to, but that's up to you. Times the square root of p hat q hat over n. And I'm going to write it like I've been writing it for the last 10 years. I'm going to write it the way Triola writes it. Z times the square root of p hat q hat over n. I also want to make a little note here. Okay, so we'll do that with the other formula. Okay, so this is margin of error. Margin of error on a good day should be between 1 and 3%. Why? Because the margin of error is the direct representation of the confidence level. If you have a very high confidence level, that means your margin of error is going to be what? If you have a very low confidence level, that means your margin of error is going to be high. Okay? So it's kind of like the confidence level of guys and girls. You know what I mean? If the confidence level of a guy is very low, you should see indicators, right? We all know what those indicators are, right?
Yeah, you take pictures, you know.
There you go. And with the toys, got to have a toy in the picture.
Yes.
Got to have smokestacks on his truck. Wear sunglasses in the gym. Versus a woman, which is real simple. And that's the Olympus. You know, got a little bit too much makeup on. You know what I'm talking about. I'm talking about those orange people. Okay? Now, every once in a while you'll have one that tries to wear the dog's clothes. We won't go there. Okay. Now, and they look silly. But anyway, there's confidence issues there. When you have confidence issues, if your confidence is high, then you're low margin of error. If your confidence is low, you'll have high margin of error. It's the direct relationship. Now, find the margin of error, you plug in what? Plug and chug. They're going to give you an example here on the next problem. I want you to do it and see what you come up with. If you can't do it, then just consider yourself a failure. There it is, same problem. Let's see what you get. I want you to do the confidence level and find the confidence interval. So I want you to give me p hat in the middle, and I want you to give me a number on the left and a number on the right of p hat. I'm going to stand over your shoulder while you're doing it. Hint, I've already given you p hat, q hat. That was the first problem we did. So you should have that in your notes. Please don't calculate it again. 90% confidence level. If you did your card, you already got your z-score. Seems like they're jumping on poor old Creepy Joe. Kavanaugh was nominated for the Supreme Court. He had a woman that said something from 26 years ago? And they all jumped on top of it. Creepy Joe gets a complaint, and they call him affectionate. I don't understand.
It is always the biggest number, right?
Yep. Creepy Joe. You know who's going to give him that. I think he's already given him that. Creepy Joe. He is a little bit creepy. You seen all those pictures on the internet with him? He is a little bit creepy. It's sad some of y'all have no idea what I'm talking about.
Yeah, who's Creepy Joe?
Yeah,
I was trying to pretend. Oh, Joe Biden.
Yeah, Creepy Joe.
I knew that.
Yeah.
Yeah.
You got 3 women now saying something against him, and everybody, and what's her name on The View? What's her name? Whoopi Goldberg said, he's affectionate. But 26 years ago, that's it. Y'all figure that out. Somebody tell me how that could happen. I'm distracting y'all, I'm sorry. Somebody remind me what P hat was?
0.63.
Thank you. P hat is equal to 0.63. Therefore, Q hat is equal to 0.37. Our 90% confidence level, dictates that Z sub alpha over 2 is 1.645.
Yes.
Okay, so these are the three things you need for your margin of error. Margin of error is equal to 1.645 parentheses times the square root of 0.63 times 0.37 over 1783. Now I want somebody to take your time and take 15 minutes and calculate those two numbers.
You want us to rotate for some?
You mean two decimal points.
Of
2 decimal points, like 0.05, 0.08, 0.0 what?
0.019.
0.019, which would 0.0 what? 0.02, which means percentage points, margin of error is what? 2%. Now we ain't done yet, because I got to give you, I want a confidence interval. I just don't want the margin of error. I want the confidence interval. So we all know P hat is what? P hat is 0.63, right?
Yes.
So I'm going to put P hat in the middle, right here. No, it's not equal to. Sorry, hold on. Please work with me, please. It's not operator error, it never is. So what is what's 63 cent minus 2 cent?
61.
And what is 63 cent plus 2 cent? And this is your confidence interval. Now, a lot of people ask, well, Hubert, why don't you put 0.63 in the middle? That's not the way the confidence interval is written. The confidence interval always has P hat in the middle. It doesn't have the number for P hat. It has, so that way you know that the confidence interval is from 61% to what? 65%. Okay? I didn't say confidence level, I said confidence interval. Okay? Confidence level is 90%. I'm 90% I'm 90% confident that the P hat will fall between 0.61 and 0.65. That's what you're confident of. Okay? Do not get the confidence level mixed up with the confidence interval. They're not the same thing. Yes, ma'am.
What is that QOCL? What is that? 9. That 8?
90% confidence level.
Oh, okay. Do not laugh. I was just. I got it.
Let me give me a crayon. For those of you, I knew Miss Jeter before she took this class, so just want y'all to know I'm not picking on her. Yeah, I am, but she's tough. She can take it.
Okay.
You're not a snowflake.
No.
What? I already went over the question. What do you want? Yes, ma'am.
I would like for you to do another,
Okay.
please.
Wait,
Let's
who raised
see.
that yet? Please. Wait.
That's the same thing.
Wait.
Oh, wait, sorry. Let me go back. Hold on. There you go.
Okay, hold on. I'm coming.
I'm keeping my mouth shut. I would say something right now, but I'm not because it's real bad and I'm not going to say it. Has to do with a vehicle I rode on in school a long time ago.
I got it. Thank you.
I used to have to go to the guidance counselor and watch the little dolphin do so the dolphin. Till my mama found out. Boy, she went up there and raised all kind of. She pulled a Medea. She went up there and raised all kind of hell. Sued the school. And people thought I was psychotic. Who hasn't put paper in the jack-o'-lantern before? Beep, 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 beep. Back then, Varenas was a brand new school. I mean, it was pretty new. It was like 6 or 7 years old when I started going there. And boy, them alarm systems worked. When that jack-o'-lantern went up in flames, that's when I had to go start seeing Do So the Dolphin, when I set the jack-o'-lantern on fire. Jack-o'-lantern. I'm sorry. Jack-o'-lantern from Belton. Okay, we'll do another one here in just a minute because I want to, let's see, that's the solution. We did that. Hold on just a minute. I want to do, well, no, I don't want to do that. Let's do this. Let's do a 95% confidence level. I'll just make up one. Let me go to the whiteboard. And I'm going to back up and add another. And this will be, I'm not going to write a bunch of wordy words. I'm just going to put end is equal to 1200 and x is equal to 550. And I want a 95% confidence. I want a confidence interval based on a 95% confidence level. I did it again. I have done that all day today. I guess my dyslexia medicine is not working.
Yeah.
I'm writing everything backwards. Confidence level. Okay, so the questional statement, this is what you need to write down. I want a confidence interval based on a 95% confidence level. I'll write that at the top. Want a confidence interval. I'm just going to put CI. Is everybody okay with that?
I'm good.
Miss Jeter, are you okay with that?
I guess so.
Okay, confidence interval is CI. I want a CI based on a 95% confidence level. Now remember, I don't want the margin of error. I want the confidence interval. So what's the first thing you do? Always find what first?
P
P hat, and then if you find P hat, you know what Q hat is. I'm gonna go up here, I'm gonna do this in blue. P hat is equal to 550 over 1200. And I'm gonna just play a little bit and take that 0 off. That's gonna give me 55 over 120. And if I divide it by 12, I'm just going to divide by 12. That would give me 10 on the bottom. And if I divided 55 by 12, 4, that'd be 48, 7, 4, 4. I'm thinking out loud. Y'all keep working. 48. 56, 56, 48. Oh, 48. 48 would be 7. I'm going to say 4.5. I'm calculating here, thank you. I'm kidding. I thought that was Miss Jeter. I got 0.45. Is that what y'all got?
I got
0.46. If you round it up.
They got to round it.
0.46. Yes.
Don't break it.
Calm down.
Q hat is equal to 0.54. Okay, so there's your two, P hat and Q hat. Now, what is the 95% confidence level? What's your Z-score at 95%? 95% Z alpha over 2. I'm sorry, what'd you say? 1 point what?
96.
So now you got all you need. So we go over here and we say Mo is equal to 1.96 parentheses square root of 0.46 times 0.54 over 1200. And somebody crank all that out.
0.03.
Now I heard the 0 really well. Then you started going,
3.
0.03. 0.03, so that's equal to 3 what? Percent. So there is our what? Margin of error. So I'm going to take my handy dandy P hat and put it right here. And then I'm going to go back to P, 46 cents. So what's 46 cents minus 3 cents? 43 cents. What's 46 cents plus 3 cents?
49.
And there is your confidence interval based on a 95% confidence level. And I'm going to tell you something. This is not hard. If you're given A, B, and C. Well, I'm going to give you the next formula, and you're going to do it yourself. Because I think you can. Well,
What if you can't?
most of you can. There's always going to be that one student that can break an amble with a banana. Right, Miss Jeter?
That's right. That ain't me.
All right, so let's do the last formula for 9.1. And I'm trying to get there. And that is this one, not that one. There it is. And write that one down. And what does N stand for? Little n stands for the sample size. Now what does that mean, Hubert? Well, let's say I want you to go out and I want you to survey some people, and you say, well, how many do I need to survey? Well, it's based on what? 95% confidence level, 98% confidence level. Let me ask you a question. Using the large number rule, the more accurate, the bigger the what?
Number.
The bigger the number. So if you want a 99% confidence level, that means you're going to have to get out and work a little bit more than a 90% confidence level. Golly, we could attribute that to real what?
Life.
Life. Wow. Work hard, be criticized for it. All right, n is equal to p hat q hat times z over margin of error raised to the second power. That's the way I write it. I don't write it like this. I write it like this. N is equal to p hat q hat times z over margin of error raised to the second power. Now, why do I not write all the other stuff? Well, one is I've never seen q hat written 1 minus p hat. That's something that I've seen for the first time in this book. Okay? So I don't do that. Second thing is, everything in 9.1 on is using the confidence interval z at alpha over 2. So you don't have to write z of alpha over 2 every single time you write down. You just have to say to yourself, we're not using regular z, we're using z of alpha over 2. So if you make those two assumptions, then you just have to write this. Okay? So with that being said, and always, this is in red, so you need to highlight this. Any decimal as an answer is rounded up. If your answer comes out 23.2, you round it up to 24. If it comes out 28.9, you round it up to 29. If it comes out 28.1, you round it up to 28, 29. You always round up. But
Thank you.
there's no such thing as what? 0.5 of a person. There's no such thing as 0.2 of a person. And what are you shooting for here? You're shooting for accuracy. So are you going to say to yourself, well, it says 29, but 28 is less people, so I'm going to go with 28. No, you're going to go with more people because you're not measuring your laziness when you're doing these surveys or questionnaires. You're trying to get accurate information. Okay? If you're pulling tires at Michelin, that's not the time for you to get LAD disorder. Okay? You need to pull as many tires as you think you need to for a 95% confidence level or above, since you're being paid, and if you give them the wrong numbers, your butt's not going to be here next year. Okay? So make sure you always round up. Now you're going to see an example here, and I'm going to ask you, what would you do? And hopefully some of y'all would say what I would do, but I don't know. Remember the anvil with the banana? Some of y'all might mess it up. Now, one other thing. If there's no P given, then you use 0.5. What is 0.5 times 0.5? 0.25. So if there's no ratio given, there's no sentence that says x is equal to something and n is equal to something, then you just assume that p hat is 0.5 and q hat is 0.5. Therefore, when you take p hat and q hat multiplied together, what do you get? 0.25. So this is based right here on, I'm going to write this in red, based on p hat equal to 0.5 and q hat is equal to 0.5. Let me give you an example, the tires. What kind of probability is a tire going to be good? Well, it's either good or what? Okay, so would you use a probability hit on tires, or would you just use 0.5? You would use 0.5 because it's either yay or what?
No.
No. It's either yes or no. It's either true or false. It's either black or white. It's either bad or good. Okay? So, meaning tires. Okay? So, if you get a question and they don't give you any kind of information on P, you just stick in 0.25 here, which is based on a true-false situation or a binomial situation, which is either this or it's this. There's no in between. All right, here's your question. Write it down because you're probably talking about 2 test questions from the margin of error and interval aspect, and 2 questions here asking for the sample size. So write this question down, and if you can't do it, just consider yourself a failure. And you should probably quit school.
I guess I'm a quit.
Probably quit whatever kind of self-improvement you're doing at home, you know. Send those back. Quit working out. And just watch Andy Griffith.
If I had a poster, it would be better.
Yeah. That's the whole problem with me as a teacher. That's why I'm not an innovative teacher, because I don't have posters. The only thing I want you to do here is I want you to highlight this in red. You know, I don't use red very much. Hope this works. You need to change that. Why? Because 3 points is not what you put into the formula. A margin of error of 3 points means what? Somebody translate that into one of two things. 0.03, good job, or 3%, which translates into 0.03. So you need to make a note here on this problem and highlight that 3. Always put the margin of error in decimal terms, because they'll try to trick you on a test and say within 3 percentage points, and then y'all put in the whole number 3, and you get some crazy answer. That's the number one error students make on this problem.
Is 82.4, is that p-hat?
That's going to be p-hat, yes. Because what is this? 90% confidence level. Put level here because they didn't put level. And some of y'all might need that to kind of kick off what you're doing, okay? Confidence level, okay, that's alpha. Alpha is 0.10, my index card, that's 1.645. So p-hat is equal to 0.824. Therefore, q-hat is equal to 0.187176. Somebody check me.
Yeah, that's right.
And 90% confident z sub alpha over 2 of a 90% confidence level is equal to 1.645. Now, just to refresh everybody, where is my? There is your, well, that's PQ, but Z over E. Remember, Z over E. So I'm going to do 0.824 times 0.176 times, I'm going to put that in parentheses, and put Z over what? E, which the E is 0.03. We're going to write this right here as .MOE is equal to 0.03. That's very important. Put that over here. MOE is equal to 0.03. And the reason it is because they put, this is what they use. They use that percentage points. And somebody crank this out. Tell me the decimal you get.
436.04.
Point what?
04.
Okay, now I'm going to ask you a question. You need to round up, of course. I want you to give me the answer, and then I want you to give me the number that you would do if this was your job. Okay, let's do the answer first. What would the answer be?
436.
437. You always round up. I told you that a while ago. If it's 0.2, you round up. If it's 0.01, you round up. Now, what am I going to use?
436.03.
440.
Nope.
430.
Nope. Large number rule. If the formula tells me I need to do 437, which that's the answer, what am I going to do? 500. Good. Whoever said that. Why? C, Y, what? CYA. Y'all know what that means? Cover your backside. If the thing calls for 436, the answer for the book is 437. If I was going to present to a bunch of directors, or if I was going to present to the department heads, or whatever you're going to be doing in the future, I'm not going to say, well, it says 436, so I'm going to do 437. I'm going to make out 437 copies. No, you're not. You're going to make out 500. You're going to make out 600. Why? Because the 90% confidence level represents 437. Anything you do above that is going to do what to your research? Make it what? Make it better. Make it more accurate. All right, let's change one thing. Let's change this to a 95% confidence level. Somebody tell me what this number is going to do.
Increase.
Why? Because of the large number rule. If you want better data, you get more people. So go ahead and crank that through. What do you got to do? The only thing you got to do is look at your index card. What does your index card say at at 95%?
1.960.
So now you're going to type that in your calculator and crunch that through, and somebody tell me what you get. That's n sub 90. I'm going to put n sub 90 right here, and I'm going to make this blue, and I'm going to put 95 right here, and I'm going to put n sub 95. Somebody just give me the decimal after you get it. $619.02. Somebody tell me what the answer is. 620. How many am I going to do?
700.
700. Now you're learning. You could argue for 650. Why am I not saying 800? Because that's going what?
That's too high.
That's too low. Because you're shooting for 95% confidence level. You want to make sure that you're going to hit that 95%. So you're going to do 620 is what it calls for, but I'm going to do 650 or I'm going to do 700. Anything after 700, you're passing CYA, and now you're going toward the next confidence level, which is 96%. Okay? Now, of course, all of us want to shoot for what? A 99% confidence level. But what's the problem? Sometimes we don't have enough time or what?
Money.
Money. Budget. You got to be budgeted. You only got so much paper money. You only got so much ink money. You only got so much this, so much that. The person that passes out the surveys, they're only paid so many hours a week. They're limited. You see what I'm saying? So you're going to have to find out, say, okay, I've only got one part-time person. I'm going to have to shoot for 95%. That's going to have to be good enough for them. And are you going to highlight that in the presentation? Yes. I'm just saying presentation. If you're presented, then what has an effect on the confidence level? What has an effect on everything in our lives? Time and what?
Money.
Money. So that's the difference between. Now on this one, I would say 650 or 700 if I was CYA. The actual answer, and I'll put it in blocks, would be 620. Okay? The actual answer here is 437.
So when you round up like to 700, are you really giving a confidence level of 95?
Yes, you're covering 95, but see, some people, you're gonna fill out a questionnaire, some people won't fill them out. So that takes away from your what? Your 620. Now you got 619 because somebody didn't fill it in. You see what I'm saying? You've got to make sure you cover that 620. You don't want to say, this is what you don't want to say. Okay, it calls for 620, I'm going to send out 620. You want to send out 650 or 700 because there's going to be some people that not, you know. And what if you got to get back 600? Then you got to what? You got to send out 20 more. Or you got to send out 50 more because 600 only came in. So you got to send out some more. You got to get 620 solid questionnaires or solid surveys. Complete. Okay? Again, this is just something, you know, of course, these are the answers they're going to ask you for. I'm just trying to teach you something here that usually in a statistic/probability setting, if you are a quality assurance person, you're not going to pull exactly 620, you're going to pull 650 or 700. Okay? All right. You're only responsible for one set of homework right now, and that is 9.1. I'm going to take the roll, and that's going to be it for tonight. After I call your name, you can skedaddle. You're only responsible for 9.1. Y'all at home, hold on a minute, and y'all can go too.